Listen-only mode.
All right, so is everybody able to hear me clearly? Hi Abru, hi Alan, hi Ashwini, hi Ella, hello Kulbir, Ritika, Yogesh. All right. Um, uh, can I make you the co-organizer? Who can I make the co-organizer today, so that I can have two recordings of the session in case mine get corrupted. I have an alternative. Yeah. All right. So can I make somebody co-organizer so that we can have two recordings? Um, okay. So Alan, what you have to do is basically click on the record button. That's it. Okay. If I make you the organizer, you just have to. Okay. Okay. So I'm going to make you the co-organizer. All right. Are you able to see the recording button? Once you are done with starting recording, just let me know. It would be in the screen sharing somewhere. You are on Mac, right? Oh, okay. Okay. So maybe I'll have to make somebody else co-organizer because Alan is on Linux Chromium. So Ashwini, I'm making you co-organizer. Is that okay? And you have to start recording. Okay. All right. Are you able to find the recording button? Okay. Are you able to find the recording button? Right, I'm back. So I had muted myself. All right, are you able to record Ashwini? Okay, great. So the okay, am I clearly audible to everyone now that the recording has been started? All right. So today we are going to discuss how to write MapReduce in Java, and then we will dive into few more advanced concepts. Before that, do you have any questions for me? No questions? All right. All right. So let's start with our discussion on how to write MapReduce in Java. Okay. So first of all, the question is why do we need to learn MapReduce in Java? The main reason is that it's the primary support. Why? Because Hadoop is written in Java. So extending Java code um, with Java is far more easier. And you can modify you can customize, I would say, you can customize the behavior of MapReduce to a very large extent. Okay. As a thumb rule, if you have a really custom requirement, such as you want to write a custom way of reading data, custom readers, then you generally go with Java. Otherwise, your Python and any other Hadoop streaming code is good enough. All right. And in the big data industry, the chances of you writing MapReduce in Java is actually quite low. Most likely, most of your work will finish in Hive or a Pig. Okay. Otherwise, you can write UDF in Pig and Hive. So we'll see that later. For now, Uh, let's start with writing MapReduce in Java. So first of all, in case you are interested in learning MapReduce in Java, it'll be a good idea to go through those Java sessions, which are provided as complimentary with the course, and in that is good enough to work with MapReduce. All right, so let's start. All right, so first of all, the first step in case of MapReduce is you have to install Eclipse. So you can simply go to install Eclipse, and the first link you get is you go to download, and under download you can download any of these Eclipse. Okay, I would go with this one. This is good enough, or this one is also good enough. Either of this or this is good. All right, and then once you're done, you can install it and start it. And while starting Eclipse, it'll ask you for a workspace. You can create a new workspace. I'm going to create a fresh workspace for this session. So it'll look as if it's a fresh project. Okay, so this is my fresh Eclipse. All right. Right now there are no projects. This side it displays the project and all that. Okay. Next is that you say new and say Java project. And for Java project, right now what you can do is you can take the project which we have listed as part of course. If you go into the course details, there is a sample project provided to you. Okay. So here you will see the, I think it's in session 4. Okay, session 4 or 5. Yeah, here is a sample project. So you can download the sample project, and once you download, you can you download this sample project, you have to unzip it. Let me just unzip it for quick time being. So this is Java MapReduce example dot this. We can simply download this project. Okay, it's 53 MB. Okay, so once that gets downloaded, it will be extracted, and afterwards we will import this project into our Eclipse. All right, is everybody with me till now? So as a first step, you download the project, install Eclipse, and then create a workspace. When Eclipse starts in the beginning, it gives you a prompt to create a workspace. You can have many workspaces inside Eclipse, and then so all right, so here we have, let me just clean it up now, the file name. Okay, I'm going to delete these two and I'll just say this. Okay, so this is my the folder which I have downloaded. If you look at this folder, it has got two main folders. Okay, it has got two main folders. One is called libraries. This library contains all the depending libraries you require. Okay, and every library is made up of jar. You can see the Hadoop HDFS, Hadoop Commons, everything I have put into a single folder. Now this TRG2 is the Java project. Here we will see our hello world program, and under this you will see my so TRG2 contains a SRC folder as well as bin folder. Okay, bin folder contains the compile code. It will be auto generated, while SRC would contain the code. Okay, and here there is a my folder, that means it's a workspace. It's a workspace, you can say namespace, and so on. Okay, so now let's import this project directly into Eclipse. Okay, so how do you do that? You say remove this default location, or you can say file, instead of saying new the way we were doing earlier, let's import directly. Okay, you go into this existing project into workspace, and then you go into where is that project downloaded? It is inside downloads, and this is the one which we are talking about. Don't click on this one, go to TRG2, because TRG2 is the one which contains your project. So TRG2 is what you have to select and click on open. When you click on open, it discovers that there is a project inside that folder, and if it's not able to detect, it will not give us this listing. Now we have trg2 opened here. Okay, you can see the code is here. So this is the entry point. Step driver is the entry point. We will go into this code in a minute. First, let's check the reference libraries. Okay, so going back to the slide, so we have installed Eclipse, create Java projects. Okay, add libraries. These are, instead of this, we have imported the project. If you're creating a new Java project, you can simply if you want to create a fresh project, you can simply create any Java project and add all these libraries provided with our sample project. These are standard libraries that are required to compile a MapReduce code. Okay, so now going back to the Eclipse. Here, sometimes it might give an error saying reference libraries are invalid. In that case, you can right click on the project node, the topmost one, right click on it and go to the properties, go to the Java build path. Here, you will see these libraries listed. You can remove these. You can remove these and add another. Okay, except for the last one, which is Java 7. Okay, you can remove these and add some other libraries. Okay, so if these are giving error, for me it's not giving error because they are correctly located. But uh, if they are not correctly located, I can say go to this folder, go to libs, not like this. Let me add all of them. Add external jar. I've removed all of the libraries and then selected all here and click open. Okay, so this is one thing. Next is you might have to uh, you know change the Java compiler. Okay, so here I'm setting something called compiler compliance level. Okay, what does it mean? That when my code get compiled, what is the minimum Java virtual machine does it require? So the tendency is that you compile your code such that the output binary can run on the lowest possible version of the Java virtual machine. Okay, imagine that your code is compiling for Java 8 or Java latest version. Okay, while and the server does not have that version. In that case, your MapReduce will fail. Therefore, try as much as possible to have the very low compliance level. And that's true for any kind of product you build in software industry. If you're building a mobile app, you will target the iOS lowest possible version or the oldest possible Android phone, so that if your application can run an older version of Android, that it can also run on the newer version. But reverse is not true. If your program can run only on the latest one, it will not be able to run the previous versions. Therefore, you keep your compliance level as low as possible. Okay, we call it backward compatibility. Okay, Finney's question is what's the configuration needed in Eclipse? Okay, so basically what you need to do is download Eclipse, download the project, and then import the project into Eclipse and change the libraries. That's all we did. We haven't done much. All right, next is Lokesh is saying, should it be Java 7 or can be higher? I would prefer Java 7. Okay. I'm not sure which Java do we have. Let's take a look at which Java do we have on the server. Okay. So, I'm sorry. First, I need to copy login, paste it. Hadoop, FS. What do you say? Not Hadoop. I'll say Java minus version. Okay, it says on server it has 1.8. Now what you see is the Java version what we have on the server is 1.8, but we are compiling for 1.7. Okay, if you compile your code for 1.6, so we are compiling for 1.6 and on server it's 1.8. So 1.8 means it's Java 8 and we are compiling for Java 6, which means that our code will run on the server. All right, now let's try to see that. Okay, so that was how you configure. The only change I would like to make is I want to change the editor font. I like to change. All right. I hope the code is clearly visible to everybody. Okay. So this is the entry point. So when you write, so let me explain how do you write the code in Java. First, you create three files. One, driver, second, mapper, third, reducer. Okay. So the fingerprint of mapper code is this. This is something from here to here. This is like empty MapReduce code. Okay, so a MapReduce, this is the skeleton of MapReduce. Sorry, this is the skeleton of mapper code, not MapReduce code. And how does skeleton look like? You create a class. This is the name of your class. You can give it anything else that extends mapper, and then it specifies what is the data type of input, key, and value. Okay, so the way when we define something in Java, we define the data type of the variable. In the same way, when we extend a generic object, we can say, we can concretize it. We can say that my stub mapper is going to take input key value in this form and going to give the key value of these two data types. Okay, so you can see that the mapper is, this is the data type of the key which is input to the mapper, and the data type of the value which is input to the mapper. Now you must be wondering that in case of our Python code, the only input we had to the mapper was the input text, but here there is key and value which is input to the mapper. Okay, so in this case, in case of Java, the input to the mapper is key and value. The key is basically the byte count. I mean, byte count, and value is the line. So the input to the map is the line, which for every line, this map function is going to be called, and we are going to be provided with the byte count from which the line is starting. So we will know from what is the byte at which this line is present in the whole file. So that's the key which we are provided. And then there is an interesting object called context. Okay, so context is an object to which we have to give out keys and values. Okay, so context will collect all the output which our map function provides. So we created a mapper by extending mapper object, specifying the data type of key and value which are input to the mapper, and key and the values data type which are output of the mapper. So now whatever you specify here, it has to be same as this one. Whatever you specify here, it has to be same as this one. Similarly, while writing to the context, so context will collect all the key values we have, and the way we send the output of mapper in the form of key value is saying context dot write, and this is one key and this is one value. Okay, now what is this text and what is the long writable? Okay, what is the text and what is long writable? I'll explain to you. So while we talk to MapReduce, while we give out the key and value to MapReduce, we cannot talk in terms of the basic primitive Java data types. We have to talk in terms of the data types, parallel data types provided by Hadoop. Why? Why did they need to create new kind of objects? Because they wanted a better serialization, because whatever key value you're going to provide, it's going to get written to the wire, written to the disk, and hand it over to various processes. Therefore, Java MapReduce guys, Hadoop guys came up with the idea of creating their object types and then accepting the data only in that format. It's like saying, it's like MapReduce telling us that, hey, if you have to talk to me, talk in these terms. Okay, I only accept the data which is wrapped in this kind of gift wrap. Okay, so that's what. So text is a parallel to the string of Java. Long writable is parallel to long. Int writable is parallel to int, and similarly float writable is parallel to float. So uh, Ella, which part do you want me to repeat? Okay, all right, let me explain again. So here we go, and actually the Java code looks little daunting, but don't worry. Most of it is like constructs, and since Java wants us to specify the data type of everything, therefore we the code looks little bigger. All right. So first line contains the package name, meaning in what folder does my code lies. Here it's in my folder, therefore we say it package my. Second is all the data types all the data types that we are going to use. Remove. Okay. All right. So all the data types that we are going to use here. So we are using long writable, we are using text, and we are using mapper. You can see that. Okay. So those are the imports, because our class depends on these definitions, these external classes. Now public class stub mapper extends mapper. This is the standard construct, and then you define that my stub mapper is a special case of a mapper which takes this key value types as input and gives out this key and value types. All right, and then here is here you will define a function saying override, means we are overriding the natural behavior of the map function which was part of mapper, and we are saying this map function is something which takes the input as key and value, and then here the context which is given to us by Hadoop. Okay, so when Hadoop calls our logic, it will be calling this function and will be passing the line, input text line, along with the location of that line in the file, and then it will be providing us something called context. Context is like a conveyor belt. Okay, or you can say context is like a big basket which Hadoop will be providing us, and we are writing into that. Our code will be writing into that basket. Okay, so you can see that context dot write, we are putting the data into that basket. Okay, and what are we putting? We are putting key and value pairs. All right, now let's take a further line of code. Okay, asterisk means the way we were saying the asterisk star, that was a comment, so we have removed it. Now here what is it that we are saying? We are saying value dot to string, meaning convert this text into Java's standard string because text is from Hadoop, and then split it based on either space or tab, meaning wherever you find the space, white space, split it. Okay, and that becomes an array of words. So after splitting the full string, each line, we iterate over each word, and then we iterate over each word, and then we write to the context. This is just an example of showing that you can interact with system.out, system.error, but these would go into logs. These would go into the logs. All right. So a question from, so okay, let me increase the font, and then okay. A question from Ashwin is, what's the use of having a separate data type? They could have used a string. Okay, good point. So what they realized was the Java's string method is not that great. Java's default serialization is not great. That's why they came up with their own tech. They came up with their own classes for representing various things. So they came up for, instead of using Java's string, they came up with text, and then instead of using long, they came up with long writable, and instead of using integer, the default integer, okay, this one is small l, small I, and they came up with int writable. Okay, and ironically, the Java itself has another representation for long, which is capital Long. Similarly, we have integer, capital integer, and that's not we're going to use. All right. A question from Yogesh is, long writable for long is what we define the type of output word. Yes. Output value. Yes, that's correct. So this is the output data type. Output data type of key, output data type of value. All right. So here we are saying we are wrapping one inside this wrapper called long writable. Okay, we are saying new long writable and wrap one in it, which means this looks like a big gift, but inside it it's a numeric one. And then similarly, even though it's just each individual word, but we are saying new text here. Okay, we could say to lowercase, to lowercase, and we could also replace, okay, replace all, and we could say not, if it's not 0 to 9, and this replace it with nothing. Good. So this is what we did. So we are saying, we are going one step ahead. We are saying string clean word equals to lowercase, and we'll just do that, and we'll say, we are saying string lc equals this. So first we converted the word into lowercase, and then we are replacing all the special characters with nothing. Okay, and then we are saying new text. So we are passing this clean word as a text now. All right. Ashwin's question is here key is the text, then value is the number. What if key and value not text? You will see that. Okay. So output key or input key, Ashwin? Yeah. You can have anything you want. So where is my Eclipse? Here. So you can have any kind of data type. You could say this will remain as such because it's something Hadoop provides you. This also will remain correct. This one you can change the output data type. Okay. This one is governed. These two things are governed by something called input format. We will talk about input format quickly. Okay. This is the input format that governs what kind of input your map function gets. Okay. A little overview again. I'm taking a step back. So what is it that Hadoop is going to do? Hadoop is going to take your stub mapper class and send it to all the machines which contain the blocks of your input file. So this stub mapper is going to be distributed on all the machines which contain the parts of your data. And once it gets there, it will be instantiated. Internally, an instance of this class will be created. Okay, an object of this class will be created. The way we say new stub mapper, that way Hadoop will also create one instance of stub mapper on all the nodes on which the data lies. Next step Hadoop is going to do is it's for every record in the input file. For every record in the input file or every line in the input file, it's going to execute map function of the newly created object. Okay, so if there are three mapper nodes selected, that means there are going to be three instances of stub mapper. But if there are a million, if there are a million records in the input, okay, in our case a record means a line. In case our data contains a million lines, we are going to have 1 million calls to this function called map. For every record, this map function will be called. Okay, some few hundred thousand times it's going to be called on one machine. Few hundred thousand times it's going to be called on another machine, and so on. So stub mapper get instantiated only once in the only once on a machine on per machine, and this function map gets called again and again. All right. So this is a very important criteria. Okay, so when you're writing your code, try not to use static variables because static variables, their scope is only till one machine, not to all the machine. If the value of static variable remains only confined to one machine. Okay, so your logic is going to be really get bad if you try to use static variables. Okay, you can try using static variables, but it's going to be quite awkward. Okay. A question from Yogesh. Does it mean that do we have to have mapper code as small as possible as an optimization? Yes. Okay. But your business need is the business need which governs how big is your mapper code. Okay. But for optimization, you need to be clever in case of mapper. Okay, so anything that happens here, you have to be a little cautious because let's say you're doing a lot of string operations here, a lot of work is again and again happening unnecessarily. You would like to make that little more optimum. Say instead of using string, you could use string builder and so on. Okay. question from Ashwin. Um, in the new long writable, what is this one? Basically, ideally, if there was no constraints of data types, we could have been giving out key one like this. The actual word from the line is the key, and the value is numeric one. Okay, value is numeric one. Right now, since Hadoop says no, you can't give me the usual Java string and usual Java numbers. You have to talk to me in terms of text and writables. Therefore, please wrap it up, wrap like a gift wrap your data in those classes. Okay, that's why clean word has been wrapped in text and one has been wrapped in long writable. Good. All right, is everybody with me? So this was our mapper. Next, yes, yes, Liu Song. Did I miss your question somewhere? You have a question for me, Liu Song? Liu Song? A question from Finny. Question is, can we instantiate out of the loop and pass to context? Okay, can we instantiate out of the loop and pass? Yes, yes. So we can basically use basically this object, whether you write here or anywhere, it's up to you. Whatever key value you want to hand over to context, you can hand over using this way. Okay, you could write something here, you could say like that. All right, all right. A question from Liu Song is, what's the meaning of one here? So basically we just want to put some value. Okay, it could be anything, because at the end of day we just have to count how many times, how many values are there for a key, because for each key if there is a value. Okay, and we will just at the end of day we group the data on the key, so all the values will come as an array. If we just have to count how many values are there. Okay, so it could be one, it could be two, it could be anything. It's just a placeholder. Make sense to you, Liu Song? Great. All right. So it's just a placeholder. We could have, say, something like text. We could have text here like this and say uh, I. Okay, we could have I. And then at the end of day, we just have to count how many I's are there for each of the key. All right, great. Now this is our mapper. This is our mapper. All it did was it broke each line into word. It'll be called, this map function will be called for each line in the input text. And then for each line, it'll break that line into words, convert it into lowercase, and then clean that word and send it to the okay. So send it to the context. That's all. So this is our mapper's code. Next is the reducer. Now reducer code is also in a similar spirit. You have the name of the package and then the imports, and it's a standard Java. And here this part is similar to mapper. Okay, so the reducer which we are talking, it's a stub reducer, extends the parent class called reducer. And again, it defines the data type. And this data type has to be same as The input data type to reducer has to be same as the data type of the mapper's output. So text long writable. Why? Because the output of mapper after getting sorted and grouped is going to reach reducer, and that's how it happens. So you have to make sure these two things are same: stub mappers output key value data types and stub reducers input key value data types. All right, next is, so each key all the values will be brought together by Hadoop into an kind of an array. It's called iterable here. Iterable means it's a list. It's something over which we can iterate. It's a many values. For each key, there could be many values. Many means zero or more. Okay? So, so for each key, there could be many values. Okay? Many as in one or more, not zero or more. And then you have context again, because step reducer, rather than returning, it'll put the output into context. Why? Because reducer can can give out as many key value pairs as it wants, not only once. Okay, not only once, but it can give out as many key values as it wants. So so it writes the data to the output, and all it does is, here it basically sums up all the ones. Okay, or it could also be same thing if we did this sum plus equals to 1, because iw.get is anyway going to be going to be 1. Okay, or we could have actually said values dot do we have, okay, we can't, okay, let me just check, iterator dot count. Do we have count over the iterator? Oh, we can't count iterator without iterating, so we'll have to actually go like this: get class, get string, iterator. Okay, no, we have to iterate. There is no function to iterate. Okay, never mind. So we both the things are equal, because iw.get is going to be 1. So we could have actually said 1 here, and then that's it. That means whatever output you put in the iw, that's good enough. It doesn't matter to us. Okay, all right. So this is our reducer. Okay, this is our reducer. Ignore for time being these two exceptions. Okay, you can choose to, you can throw these exceptions. These exceptions get thrown in these code. So exception is something when some error occurs, that exception is thrown. So instead of catching that error while writing, so these two errors could occur while writing the data here. So reduce could have handled it separately and done something, but instead it says that I don't want to handle it. I just want to throw it. All right. So these are two classes, mapper and reducer, both written in Java. Looks little complicated, but it's not that complicated. The actual code is only this. The actual code is only this in reducer, and actual code is only this in mapper. Okay, and in the driver class, okay, and in the driver class you have this something called okay, so a step back. So we wrote two classes, mapper and reducer. The third class which we need to write is driver. Driver is the entry point. Driver is the one which we are going to call via Hadoop. We are going to tell Hadoop that, hey, here is my driver class, here is my entry point. This class contains our main method. And what does this main method do? It sets up our MapReduce job. It sets up our MapReduce job, and it calls the MapReduce job. How? By creating first a job config, then a job details, and then setting a mapper class of the job, setting a reducer class of the job, telling the data type of key and value and input key, output key, and all that. Now, next is that it also tells job that here is the data. And what's the data is passing? It's passing argument 0, which means the first argument that is passed to our data, that is the data which we are passing. And second, and here again, the data which we are passing to the job. So this is the way we are creating the full job. Okay, so a job definition is how we convey the details about our MapReduce to Hadoop. Here we are telling that, hey, here is my mapper class, here is my reducer class, and here is my input data, and here is my output expected folder. Okay, and once we have set up the complete details of job, then we say job dot wait for completion, and we say true. Okay, so we basically wait for this job to complete, and once that is done, we exit the Java virtual machine. So this class is what actually launches everything. It basically configures and controls and does everything, okay, that it wants. Similarly, it can also set up number of reduced tasks, okay, and it can also set up other configuration properties. Okay, we will go into more details as we go forward, but for now let's try to run the MapReduce. So Alan's question is, the driver is an alternative to specify or all of these things in command line, or no? So answer is no. It's basically the driver is the way to call the job and configure it. Good question, Lokesh. Lokesh's question is, so driver need not extend any specific class, but just a custom class. Yes, that's right. It just need to be a custom class. It just need to be just another class. It doesn't need to explicitly extend anything. It just have to have the main method that takes some argument. Okay, whatever arguments we are going to provide in Hadoop jar, that's going to come here. Okay, after our class name, everything is going to be here. Okay, whatever we specify on the command line is going to come here. All right, so Hadoop command, Hadoop jar command, is going to take this class name, and then whatever the remaining argument is going to pass here. Okay, so a question here is that we are setting output key value. These are overall output key. Okay, these are the overall output key value, while this is our output key value of the only mapper, this one. This is a text and long writable, and here also it's a text and long writable. You can see that. Okay, this means that it's a output of the final one. All right, good question. Fine. So now we have created our driver, mapper, and reducer happily. We made some modification here. We converted it into lowercase, removed these special characters, and all that. All right. Now, the next thing we are going to do is we are going to export it into, we are going to export it as jar. Okay. And how do you do that? We go into project, and no. Okay, where was that? Okay, wait a second, I've done that already. Okay, export and click on jar file, and then we basically can give the name to it, like now we say apr9 dot jar. Okay, and where is it going to store? Let's just store it in downloads. Okay, we're going to say apr9 dot jar. What does it say? Okay, it says resource is out of sync. That's all right. Resource is out of sync. That's also all right. Okay, all right. So done. Now let's check if it is there or not. So we said file export and it was exported. So this is our newly created Java class. It's only 6 kilobytes. Okay. Now question is, how do I take this file to my e.cloudxlabs local folder? Okay. How do I take my jar? Okay. How do I take my apr9.jar to e.cloudxlabs local folder? Anyone? Not HDFS, but e.cloudxlabs home folder. Yes? Anyone? Prem says Vince SCP and Yogesh says SCP. Any other suggestions? Ravi says using Hue. Okay. Any other suggestions? But if you do Hue, it will go to HDFS. Then yes, then we have to say copy to like local. Correct. So what we'll do is we'll do it in two steps. Okay, two steps. Okay. So there are two ways. Okay. First way is SCP. I'll say home folder downloads. What was there? apr9.jar into Sandeep90. What was my login name? Sandeep Giri 90249. Okay, at e.cloudxlab.com. Okay, so it will copy this file to the. This is easier way, as in straightforward, but this goes on great on Linux/Mac, but on the Windows machine you will have to download WinSCP and then do the same thing. Okay, then upload. That's first way. Second way is little longer, but it works. Second way is upload into Hue and then do Hadoop fs copy to local apr9.jar. Okay, this is what will copy this file to local. All right, so we'll follow the second one, because this jar is expected to be inside the it has to be on the e.cloudxlab local. Okay, so where is the. Okay, let's just upload my file. I select my jar and Okay, it's getting uploaded. Good, it got uploaded. Now I go to the console. Where is my console? Here's my console. I say Hadoop. I'll just copy whatever I edited. Here I go. Okay, let's try to say Hadoop dot jar apr9 dot jar. This is how we are going to run our program. Now it says that you have to specify the main class. And what's the name of main class? Our name of main class is my dot stub driver. I'll show you what does it mean. Main class is this driver class, and it is inside a package called my, and therefore we are saying stub driver my dot stub driver. Okay, it says that now it has successfully run our program. You see that it's showing the error which our program is supposed to show. Okay, it says you say stub driver input directory output directory. Okay, so you can see that it's working fine. Okay, now let's give what's the input directory. We will say data mr word count. This is the data which this is the folder which contains my big.txt. Okay, data mr word count, and here I'll say apr9 java. This is the output folder I'm planning to create in my home directory. Okay, if you try to specify some other location in some other folder, you might not have permission to create this folder in that directory. Therefore, try to create this directory in the output your home folder. Okay, a very good question from. So it has successfully run. I'll explain your question, Yogesh, in a minute. You see that it has run successfully. Okay, and let me just check if it has been created or not. Go to hue, sorted by the date. I think yes. Good, it has been created. The data has been sorted and key value pairs are generated. See that? These are the key value pairs. I'll say go to page number 50, and here you can see all the details. All right, so we were able to successfully run a Java MapReduce program. Everyone with me? A question from Yogesh is Java class has to be deployed in all machine as map function to be run on all the machine. So that's the duty of Hadoop jar. Okay, so what command did we run? I'll just copy paste that command here. All right, then we ran this command. So I'm going to copy paste these commands to all of you. Okay, send to all. Similarly, I'm going to put it here. All right. In case you want to use the SCP, you can use similar kind of command for you, but it's not required. Good. So we are able to run our MapReduce happily. Okay. A question from Alan is that so Hadoop streaming dot jar is one of these drivers. Yes. It also contains a pseudo kind of bridge mapper and reducer, which basically whatever you pass as the argument, it hands over the key value to those binaries and so on. Okay, so there'll be a streaming instead of saying bridge, we can say streaming mapper and reducer. Basically, it'll convert the key values provided to it into input to your program and capture the output and then put it to the reducer. So those kind of thing it'll be doing. All right. So I hope you all are on the same page. Everybody is with me. Yeah. Great. Any questions at this point? All right. Let's move on. Let's move on. So this we were able to run it successfully. We went through all of this and we went through all of these steps and done. Now there are a few things I would like to explain further because no Java code or no code is complete without testing. Therefore, also you notice that when we try to run our jar, it took a long cycle. We have to first compile it, create jar, and then upload it, and then run it there. It's a too long cycle, and it's not a great thing to have in the production. Okay. Instead, and secondly, we're trying to run it in a production, which is not a great idea, right? In typical sense, in an organization, you would have a separate MapReduce cluster for trying it out. But even if you don't have that, you can still run it in a sudo mode. And how do you run it? Using JUnit test cases. So Hadoop came up with something called MRUnit, which is a special case of JUnit. So you can actually write stuff. So you can actually write the MRUnit test cases. Okay, I'll show you. So here is one sample test case we have provided to you. All right. Okay. A last question is, can you compare yesterday's way of doing things? Okay. So yesterday we did not need this heavy IDE called Eclipse. Okay. We basically did everything inside Nano. That was the first thing. Second, we did not. So in case of Hadoop streaming, so in streaming versus Java, okay, and streaming versus Java, the mapper gets key value as argument, and sorry, mapper get key value as input std in, okay, as if somebody is typing to your program. Okay, while in case of Java we get key value as argument to our function. Okay, that was the first difference between Hadoop streaming and this one. Second, yesterday we used the IDE as Nano. Nano is like a very rudimentary text editor, and today we are using Eclipse. Yesterday we did not have to download. Did we download? No. Sorry, not download, upload. No. But in case of Java, we had to upload first Eclipse, then copy to local. Okay. Now in reducer there is a major difference. In the major difference, okay, you get you get ordered key value as std in. Std is as in data on standard input. Okay, that's what you get. Okay, that's what you get. Okay, while so that's you get key value as standard input, while here values are grouped. Okay, values are not grouped, only sorted. So that's a major difference. Yesterday, the difference between streaming versus Java. So a question from Ashwin is how exactly Hadoop will load drivers in yesterday's case. Actually, yesterday the so today we wrote our jar, right? In so somebody in Hadoop's team wrote Hadoop streaming jar, which basically contains the stub driver, stub mapper, stub reducer, and stub mapper, stub reducer. Basically, instead of doing any logic inside, it basically call external programs. That's all Hadoop streaming does. Okay, take a look at the code of Hadoop streaming. It's pretty straightforward and it should be very clear. All right, great. So Ila, was this differentiation clear to you between streaming and Java? Everyone, are you with me? All right. Yes. So Alan's question is, so we don't get grouping with streaming. Yes, we have to do it by ourselves. We have to do it by ourselves. And grouping and ordered data is not a big deal. Next follow-up question from Ellen is, we would have to do that in our own reducer. That's exactly right. That was the only, upsetting part for me when I looked at the reducer in streaming. But later on, I realized that it kind of matches the philosophy of Unix pipes. Therefore, they did not do the grouping. All right. Okay. So take a look at the test cases. This stub test is a class which basically can be run right away. I'll show you first. Run as JUnit test case. So it's testing reducer and testing mapper, testing map reduce. There are three test cases in this class, meaning there are three functions which are starting with at text, which have the annotation called at text. Okay, so these three, out of these three, one is failed. We have purposefully made it fail. Okay, so as I was telling you in the previous session, that you always test mapper and reducer independently, and then you test map and reduce together. Okay, so for that what you do is you create these dummy drivers provided by mr unit. So first you define them, then you create their instances by saying new map driver, new reduce driver, and new map reduce driver, and set the actual class, the class that you have coded into map driver and reduce driver. Okay, and in map reduce driver you have to specify the mapper and reducer as defined above. Okay, so we created three things. One is map driver, reduce driver, and map reduce driver here. So this code of MR unit will not be testing our driver code because it has its own drivers. Okay, but it will be testing our mapper and reducer. All right. So inside the mapper, we are saying map driver dot set data. We are setting the data, and then once we run the test case, we are we are saying map driver dot run, and whatever is the output, we are testing whether it is correct or not. Okay, whether it's correct or not. Okay, a question from Ella. What will be some use case of using Hadoop streaming and of using Java? So the thumb rule is that if you don't have too much logic to be built, you generally go with the language which you are good at and do the Hadoop streaming quickly. If you remember our first example where we used shell, it was actually quick, very quick to do the word count problem. But then we used Python that was little slower because we had to write code, use the text editor, and then we used Java. It was little more bigger. So bigger use case. So the thumb rule is that whatever language you're comfortable with, you write your MapReduce logic in that. Okay. So at the end of day, both do the same thing. Both are basically at the end of day, it's the same thing. If you need far more control over things, you may want to go with Java one, but are equally equipped with running with Hadoop streaming. Use case wise, both are almost equivalent. All right. So this was our example of running the test cases. You go through these test cases and you will have a clear idea how to test your code. Okay. All right. So that was our test case. All right, so that was our simple Java code. Now let's go into some of the advanced concepts of MapReduce, because under the hood, MapReduce is having many customization abilities, and let's look at those parts. There are a few more ideas like partitioner, combiner, and other, and chaining. We'll go through those as well. All right. So should we move ahead? Is everybody with me? All right. A quick question to everyone. Will you use streaming or MapReduce? Okay. It's not a question. It's more like survey. So will you use streaming or MapReduce in Java? Will you use Java or streaming? Given a smaller use case. So say all the four problems which we have given earlier in the session. Which one will you use? Ravi says I'll use streaming. Alan says streaming. Finny says Java. Okay. Prem, Abru, and Kulbir all say streaming. Yogesh also. And Ella also. Okay. Okay. So there are. Okay. Okay. Wow. So except for three people in the class, Finny, Lokesh, and Ashwin are from Java background, and Ritika Okay, Ritika will also say streaming. Good, good. So, except for three people, everybody would like to do using streaming. Okay, and honestly, if you ask me, even though I am a Java programmer, I would actually go with streaming, and that's what I did. Okay, that's more reasonable, Yogesh. Unless if I feel I'm not able to build the logic in Unix, yes. If I'm not able to use logic in Unix or Python, I will only then I'll go to Java. Okay, good, good, brilliant. So everybody with me. Now there are a few more ideas. Let's just get into those. All right. So we briefly talked about writables. Okay, it's like Hadoop saying that when you come to my party and you give to me any gift, okay, always wrap it in the paper called writable, or wrap it in a box called writable, right? So what Hadoop did was Hadoop created its own interface called writable and for created the classes for handling uh, the basic data types like long writable, int writable, and everything. Tomorrow, let's say there is a customer object and you want to hand over this whole customer object till the value. Then you can create your own custom writable object by extending or by implementing this interface called writable. You could say my object implements writable, and then you will have to you have to basically implement a function called read fields. Okay, so basically what does it mean? It means that when the need arises, your object knows how to convert an input data into your whatever form, okay, from any data input stream. Similarly, when system asks your writable that give me the stream, it should be able to give. That's all. That's all it means by writable. Basically, Hadoop is ensuring that conversion from a file stream or a normal network IO in and out are done by your logic. Okay, so if you are creating your own custom writable object, you should know how to deal with the data input stream. All right, so this is what it's going to do. Prem's question is, as per your experience, is there anything which can be done by Java and not by Python? I haven't, stumbled upon the use cases, but sometimes there are hard requirements of using Java, or sometimes there are hard requirements of using Python, and so on. From the organization perspective. All right. So I hope everybody is clear about custom writable. Okay, so the first problem is which we also told yesterday, that create now you don't now you have to create the actual code of map Java MapReduce or Hadoop streaming MapReduce. Either way, write proper code and in whatever favorite language you have. Okay, and create a GitHub repository and publish it there and share the repository link with us. Okay, and while you are creating, please mention no big data in the readme.md. Okay, so that we get some visibility. And for you, it's going to be a good thing because that'll be your first GitHub repository code. It's okay to have very dirty code public. Okay, do not worry about dirty code being public. It will be all right because that's how everybody starts. All right. Now, this question which we told earlier, did anybody work on it? Yes. So nobody does the problem. Alan says that he wrote it in Python. Good. Very good. Anybody else? So the idea was to produce these, we call them n tuples. I'll explain to that again. So when we type something on these new keyboards on say Android and anything, they give the next word suggestion. Where does this next word suggestion come from? It comes from doing the frequency analysis of Hughes text. Okay, these are pre-computed correlations that these are the five most popular words that follow a particular word. And how would you do it? If we are talking about the corpus of entire entire World Wide Web, it's around 500 terabyte. And if we had to do that, how would you do it? You cannot do it without using MapReduce. You cannot do it in R. You cannot do it in any of the usual tools. You will have to have a MapReduce kind of arrangement to churn that kind of data. And how would you go ahead here? All right. So, anyone, any suggestions? What will your mapper do? What will your reducer do? Imagine you have a huge text file containing all the text from the World Wide Web, and you want to prepare based on this text. You want to prepare the key and the five values which come frequently together. Alan says I extracted bigrams in Mapper. All right. So Ella is saying, can you go to this website? I'm not. Yeah, I think the steps have changed. So the steps are not clear on their website. Recently, they have also done some changes. Okay, so you can basically have made some more changes to it. Okay, or you can use some other place from where you can download the data. It's not pre-prepared. You'll have to run this wiki extract.py. Okay. So Yogesh could also not succeed from the website, but you can use some other way to download data from Wikipedia. Okay, you could use some other ways, or you can run this program which they are giving. All right, I'll also take a look at it again. All right. All right, so let's discuss a little bit of a strategy here. Okay, even if let's say big.txt is the data we have and we want to prepare this, so you could use big.txt itself as an example right now. Okay, all right, so I'm going to take you through the example which I have here. So let's say this is the text. First line contains how are you? Second line contains Ram dot happy birthday. Then third line contains to you happy new year. Now in the mapper, if you remember our discussion earlier, our mapper function, the map function called on every line, right? In our mapper function, we get only one line at a time. We don't get the whole paragraph in a single shot. Now, based on that, for every word in the line, we print word and its next word and its next word and its next word, and so on. Right? This way, all the words that follow a particular word will come together in the reducer, and in the reducer, we can do the frequency analysis of those words which come more often together. All right. Do you see any problem with this approach? Think about it, and let's do it after the break. Okay? Break for 10 minutes and back by 9:42 p.m. IST. All right, so I'm back. Should we start now? All right. Okay. So the approach which I have given and outlined here, is it good? Our mapper is giving key and value, and then all the words which are following a particular word will be grouped together. A question from Ashwin is, group the values which occur more than two times, but how do we know here? Okay, because unless we group it, we won't know that it has two values, or twice it has come twice or thrice or only once. Alan says, won't you have another sort in reducer in order to get top 10? Yes, and that's one of the problems in this approach. Kubi's point is, some pairs do not make sense. For example, Ram happy and you happy. That's correct. Why? Because here the sentence is finished. It does not mean that happy should be suggested after Ram, because it's one of the case and it's basically a second sentence. Similarly, happy birthday, sorry, but you and Ram should be basically coming together, which is not there. Very good point, Kulbir. Any other problems do you see with this? Okay, so we are that's pretty much actually. One first problem which in this approach is the computation of the frequency can be made further faster, because right now what would happen is that the frequency computation would happen on the reducer, and that requires first again finding top 5 amongst all the values. So create um, you will have to kind of create frequency table again in the reducer. Second problem with this approach is last word of the line should pair with the first word of the next line, this one. Okay, and third problem is the last word of a sentence should not be paired. These two should not be paired, right? Because that's not a valid suggestion. Okay, now, question is, how do we solve it? The first one, where computation of frequency can be further made faster, it can be done by creating the key as a combination of the key value. Okay, if you prepare the tuples like how and r as part of the key, and the value is just one, so you first map reduce phase, you do the computation of these pairs, and then in the next map reduce phase you can basically do the remaining count. All right, that's another problem, we'll discuss it again. Now these two problems, how do you solve these two problems? Right now the main problem is that our map reduce is getting the data line by line, and what we want is we should get either paragraph by paragraph or sentence by sentence. Now bigger question is, how do you control how do you control in what form the data is received by your mapper, what contains the key and the value that are received by the mapper. So what is it? How can you control it? And that's when the idea about input format comes into play. Okay, input format comes into play. Let me explain something which is very, very important. This is something, it basically took me a while to understand in the beginning. So all of you, please raise your hand and ask the question immediately in case you have any doubt about this. Okay, this is a little very important point. So in HDFS, the data was ruthlessly cut. Whether the boundary of 128 megabyte was in the middle of word, middle of character. Why? Because sometimes character is of 2 bytes, like in a multi-byte formats. Okay, so whenever a block reaches a boundary, it is the data is cut into two parts. Whether it's middle of line, middle of word, middle of character, it doesn't matter to HDFS. It doesn't really matter to HDFS whether in what format is the data, and and whether it's cutting in middle of the record, middle of each character or each byte, it doesn't matter. So the way it does is the HDFS basically, without looking at the data, it just cuts it. HDFS doesn't look at the data as plain text file or binary. Instead, it looks at the data in the form of zeros and ones. So you can see that HDFS under the hood has cut the data like this. Imagine that. So this diagram and the examples below are a little different. Okay. So imagine that you have 11 lines. 4 lines and 4.5 lines are in first block, and second block contains little bit of fifth line up to some part of ninth line. Okay, and third block contains 10th line and 11th line and some part of ninth line. So these are the three blocks of HDFS: block 1, block 2, and block 3. And this is another example, we'll not talk about it now. Okay, make sense to you? Now when we deal in map, okay, so when we run MapReduce engine, before our mappers are executed, this raw data is converted into something called input split. The blocks are converted into input split by finding the boundary of the data. Okay, by finding the boundary of the data, input splits are prepared. Input split contains the complete record. They don't have partial records. Okay, and here a record means a line. The definition of record is another thing. Right now we are assuming that the definition of record is there. So definition of record comes from something called input format. Okay, so basically before MapReduce are executed, the first thing that happens is the data which you want to read is converted into meaningful form. It's converted into input splits and records. Okay, so here you can see that there are three input splits. This section of data has been transferred to this computer. Okay, so the section of the data has been transferred to this computer from here to there. Okay, so this piece of data has been transferred there. Okay, similarly this piece of data has been transferred to this computer. So node 1, node 2, node 3. On node 1, input split is created. Node 1, node 2, this part is created. Node 3, this input split is created. Okay. So there is a minor transfer of the data from node 2 to node 1, node 3 to node 2, and so on. Make sense to you? All right. So when the data was sliced by HDFS, it created three blocks: block 1, block 2, block 3. Make sense? And now, when we run MapReduce, how would it be? How would our word count work if it's getting half words, partial words, and so on? It look really bad, and it look as if the data has been corrupted, right? Therefore, before MapReduce is run, input format creates input splits. Input splits are created. Input splits are very much parallel to the raw data blocks in HDFS. So input splits are created on top of blocks, and input splits contain full lines. Okay, some partial line, half of the line that went to the second block, get transferred to the previous block, and so on. Now it's clear, Ella? Yes. A further question from Ella is, if there isn't a space, then how does it get transferred? So it's for running MapReduce. For running MapReduce, records are created, and records are being passed to MapReduce engine. And that point of time, this each record while get transferred and would partially stay in the memory. Okay. Prem's question is, who creates input split? MapReduce, Hadoop's MapReduce engine calls input format to create input split, not HDFS. And it's not permanent. It's only for during the process of running the MapReduce program. Okay. A question further is from Prem. Based on what logic does input format create input split? Okay, there are many kind of input formats. The one which we are right now using is called text input format. And what does text input format do? It creates records where each record is a line from text file. Okay, had we been dealing with a music file, then our record, each record could have been a music file, or it could have been something else. Or you can think of it had our data been in the form of a say kind of jar file. Our input raw data could have been a jar file. We would be using a different input format, and then in that case, each record means something else. Okay, so based on the problem statement, we choose something called input format. Our data, based on the data that we are going to consume, we choose input format, and that input format decides what is it that we receive in our map function of our MapReduce. Okay, if we are dealing with say I'll go over this input format again at later point of time. Okay. So question from Ashwin is, how does the MR will get to know this is a partial word? Very good question. Input format detects that part. Okay, input format detects that part because HDFS will, so unless a space is and unless a new line is encountered, the record is not complete, right? And therefore input format will keep on moving across the boundary, okay, unless a new line is encountered, because we are trying to deal with the text file, and text file input format behaves that way. It keeps on looking out, it keeps on reading a line unless a slash n is encountered, a new line is encountered. A question from Yogesh. At what step does this happen? Is it when we store the file in HDFS or while running the job? While running the job. Okay. A question from Ravi. You mentioned that a small data transfer happens between node. Wouldn't this small transfer become huge for large data? So it depends on the choice of the what do you call input format. I'll give you a very interesting example. Input format. One of my student, what he did was he created a huge file, and the whole file was a single line. It was a single line. Okay? A single line of 1 GB. Now, what would happen? This is something very interesting. So, what happens had our big.txt been of 1 GB, but it was a single line, right? And our map function, as we told you, it will consume the full line. It will be given a full line as key, as you can say, as the input data. You'll get the full line in a single shot. In that case, what would happen is, even though HDFS will have 8 blocks, but there will be one in one input split. One input split with one record. There'll be one input split with one record. It's like one record, like first one itself being broken all across into 3 records. Do I make sense to you now, Ravi? And I think I answered Ella's question as well. Okay. Yes, Ashwin. Just give me a second. There are a few more questions. Your question will be addressed in a minute. Okay. So you know what happened in this case? He created this 1 GB text file, and his MapReduce was overflowing memory, because what was happening is the whole line was being loaded into the memory, because key values are loaded into the memory in HDFS, sorry, in MapReduce, and therefore it was overflowing even the map task. Okay. So So yes, it could happen that if there is a very big file and a sentence or a paragraph, okay, to be on a separate. Here I'm saying, let's say if there is a line on multiple nodes, right? Somebody forgot to put slash n in a big 1 GB file, and then, or in other words, let's say there is a 1 GB file of say zipped file. Zipped file don't have slash n, and you are trying to use input format of text file. So again, you will get a memory overflow. Liu Song's question point is, can we say input format handles data logically while block handles data physically? Yes, exactly. So input format is a logical representation. Logical means it makes some sense to us. A block, a raw block which has been cut without uh, caring about the boundary, would not make much sense to us. Had we been dealing with a jar file or a zip file, this block, individual block of that zip file wouldn't make any sense to us. We'll have to bring it together in order to unzip it. Okay. Ashwin's question is, can we customize to take the record up to full stop? Yes, we can do that. Brilliant. And that's what I wanted to convey. All right. Was I able to answer your questions? No? Physically, the data is stored without much meaning, but the meaning depends on your requirement. A text file you might want to you might want to run paragraph wise, line wise, or maybe word wise, and so on. There could be many ways to deal with the situations. Make sense to you? Ella, you have a question? Okay. A question from Ella is, in the scenario where the sentence is on a block, on and block 1, I'm assuming that's what you mean. In the scenario where the sentence is on block 1 and 3, because 2 already had data on it, and then how would. Okay, I did not get this one. In the scenario where the sentence is on block 1 and 3, because 2 already. No, so here we are not talking about some nodes. We are talking about, say, there are two nodes, node 1 and node 3. Node 1 and node 3. And sentence goes up to here. Okay. So, so is this what you are meaning? So, so there are two nodes. Okay. Let's call them node 1 and 3. These are just the names. Okay. And there is a sentence which is quite huge, and there are two blocks, block 1 which is on node 1 and block 2 is on node 3. Okay, so the sentence is really big, going from here till here, right? Now what is the question? Okay, so again, so if we are dealing with, let's say this is a sentence we are talking about. So what would happen is it'll try to create one input split and input split 2. Okay. So as soon as it captures, let's say a new line has reached here in the text, new line comes here. So this data will be transferred to the first node. Okay. This data will be transferred to the first node. All right. So yeah, so it doesn't matter. So we are talking about, there are two three things we are talking about here. There are many nodes in the in the system, and when we talk about MapReduce, it doesn't matter how many nodes are there in the system. What matters to us is where is our block available. This is our block 1 and this is our block 2, right? That's what matters to us. Aswin's question is, what if memory is full in the previous node? Okay. Yeah, in case the memory is full and we are trying to transport the data from here to there, most likely you are going to get error. Okay, because each record has to be really small, and that's a choice you as a developer have to make. The data you are going to deal with, the record definition of a record should be should by definition the record has to be something that could be loaded into the memory, and that's something MapReduce assumes. So in this case, you know what we did? In this case, what we did, it was a single line here. There, he forgot to put the slash n. All we did was replace space with a new line. Or there was one more situation we could have done. We could have loaded the data using text input format itself and tell that our records are separated by space, not a new line. And that could have solved the problem where there was 1 GB single line file. Okay. Somewhere on the forum, this is mentioned. Somebody has faced a similar problem. Okay. Good. All right. I think a question from Liu Song. What is memory size per node commonly? Per node, I think this is what you meant. Is that what you meant? So memory size is generally, in our case, it's around 4 GB, but we dedicate very small amount of memory to each task. We generally go up to 128 MB or say 200 MB, 200 MB of memory to each map task, because there could be many tasks, many map reduce running on the same machine. Therefore, we try to limit the memory of the map task based on what's the total system memory, how much do we want to dedicate it to map reduce, and how many processes we are, how many tasks are we allowing on this machine, and we divide it, and then generally it comes out to around 200 to 300 MB per map task. Okay, a question uh, from Ashwin. Then, if there are 10 lakh words and only 5 nodes, then the total records are split by space. Then how will that work? Then, okay. So what would happen is that it'll actually split very fairly. Okay, it'll split very fairly. So it will basically, your map function is going to be called 5 lakh times. Okay, map function is going to be called not 5 lakh, 10 lakh times. Okay, 10 lakh times and 2 lakh on each machine. Why? Because each record is equivalent to a word, right? As we said, if we say that while parsing the text file, let the record separator be space instead of a new line, therefore total number of records are going to be equal to the total number of words, because every word is a record, and every word being a record will will be calling we will be calling a map function for every record, and that is every word. Okay. All right. So that was a brief discussion. This is a very important discussion, and this is something which is inherited by even Spark and everybody. They have the same definition of input split and all, and they have the same definition of input format actually. All right. So this is the reason why input split and block has to be different. So this is one block one, block two, block three, node one, node two, node three, and block. This is input split one, two, three. Okay. Now again, a input split is Hadoop divides input into pieces called splits. One mapper's instance, the stub mapper class you created, the instance of that mapper, as in the loading of that class, would happen only once per node, per input split, and split consists of many records. Each input split is many records. You can think of input split as one page at a time. Okay, so generally, you could create as small as possible input split, but a very suggested one is closer to the size of the input format. If you try closer to the size of the block, if your input split is too small or too big, then block, then what? Then there will be a lot of data transfer. If the boundaries are of input split and the HDFS blocks are varying too much, there will be too much of data transfer, and therefore, okay. So you try to keep the input split as much as possible to reduce the network transfer. Prem's question is input split size is determined by us. It can be determined by us in certain input formats allow you to define input split size. Okay. So Liu Song's question is, how about too big split? Imagine being for a file that contains 16 that contains 16 blocks, meaning we have 2 GB file and it has got 16 blocks, and for 2 GB we have created a single input split. Okay, what would happen is for this input split, one map task is being created. That means it's going to run only on one machine, and hence all the other data has to be transferred to this particular machine from all the other machines. Ok- Okay, that was a question from Liu Song. Okay, so too much transfer. And the next question from Prem is, then how will we know the block end or logical end of the file? Block end or logical end of the file. So logical end or the block end are basically are marked in HDFS. HDFS can tell you that this is your file, these are the blocks, and this is the last block, and this is the first block. Every block boundary is marked by the byte count. Okay, whether greater or smaller, it's all right. The only problem is, as you are saying, yes, sort of. Okay, slightly should have slightly. Otherwise, what would happen is, if our input split is smaller than block size, there will be one extra input split. That's what I think you mean, Prem. All right. Each input split is further divided into records. A map function is applied on every record. Record is a logical entity. The analogy of record is RDBMS, RDBMS, not MBS, RDBMS. So, so analogy is a data row, is a record, or line of a plain text file. Okay? And who creates records and input format, input split? It's an input format. Input format is a class that decides how the record needs to be created. Okay? Okay. So there are many input formats available to you, already created by experts. So an input format creates raw data, creates records out of raw data. Okay. So input format is the one, it's like a parser which loads raw data from the data blocks and create input splits, making sure that the minimal amount of data transfer happen over the boundaries. Okay. So that's what is the definition of input format. There are many available by default input formats are there, and it's a very important topic because uh, lots of people actually get stuck at this point. Lots of people get stuck at this point. They do not pay attention to input format and end up doing a lot of data transfer for running their MapReduce, and eventually their overall work is actually slower than that's being done on a single machine. Just a single mistake. Just a single mistake of choosing a wrong input format, and the whole data gets, all the blocks get transferred to a single machine to run it, and effectively their overall work is slower than what it was on a single machine when they were running it, and they keep on crying saying MapReduce is slow, MapReduce is slow. And it's a true case. I've seen many people suffering from the same thing. Okay, so somebody was one of the I think some telecom company. So they came to me saying this text format is their text format is XML, and they need to load the data at really fast pace, and they want to compute certain things out of it. So I looked at the way they were processing. They were actually trying to load the whole XML, and their XMLs were in gigabytes. They were trying to load the whole XML, and that was a very wrong way of dealing with it. Okay, so we figured out that inside XML structure there were boundaries of record, and then accordingly we created a small input format which will basically detected XML boundaries and created records, many records out of a single XML document, and divided the work. Okay, so basically it's important to know that there are many input formats that you can utilize right away. Okay, some of them, the default one which we have been using unknowingly so far, whether Hadoop streaming or this Hadoop Java, Java MapReduce, in both the cases under the hood is the input format that's being utilized, and Hadoop streaming also allows you to specify which input format class do you want to use. Okay, so you can take a look at their documentation of Hadoop streaming. So it gives you the details about various kinds of input formats. Okay, so so text input format is the one which we have been using so far in streaming as well as Java code. Now text input format allows us to set the config in the code as this delimiter. We could say, we could go to a driver class, and here we could say things like job.set, sorry, job, so conf.set, yeah, conf.set, and we could pass this. Okay, we could say things like this, and we could say our delimiter is say dot. Okay, so this delimiter is now, instead of being new line, it's now dot. Okay, so it will break the data based on dot. All right, so a question from Ashwin. Please show us a practical example of a huge text file, and let me get a 1 GB file. Let me get a 1 GB file and try. Okay, or you can try it by yourself. All right. Now, next question is, where do we set the input format? So we can always say job dot set input format class. Okay. So here we can set, if our file is in a fixed length input format, we can say this thing. All right. And by default, it's the text input format. And we have text input format. Okay. Okay, always use the class which contains MapReduce. Okay, because they are related to the MapReduce 2. Okay, so use MapReduce 2. And all right, what all argument does it provide? It doesn't provide much arguments. All right. All right. So you can control which input format you're going to use by using job object and the specifying the input format. All right. So and say you want to, this time you want to do that each input is split, meaning each map task should only get fixed number of lines. So you could use n line input format, that's again provided by Hadoop in the default library. Okay, and you can say that each lines per map is this much. Okay, we can specify this configuration be using conf.setconf. Okay, so let me check if n line input format provides something to us. So you can have set number of lines per split. We can say this kind of things. Okay, we could say this. So n line input format provides us this. We could say job dot set input format, and we could say n line input format class. Again, all right. So this way we can specify the n lines input format instead of text input format. Finney's question is split equals to set of 100 lines or some number. Yes. What about block? Block is basically created by HDFS and has nothing to do with MapReduce. MapReduce loads block and converts it into the split. Input format converts a block into a split. All right. Good. Good. All right. Liu Song, you have a question for me? You've raised your hand. Now, sometimes you are trying to load a file which is not delimited. What does it mean by delimited? Sometimes the data, instead of being delimited, it's essentially fixed length input format where every record has got fixed length. Okay, and there is a padding in case the data is not sufficient, and this fixed length input format is quite common in the database files where every record has got a fixed size and so on, right? So question from Prem is by default which input format is used? By default, everywhere in MapReduce, by default it thinks that the input is text input format. Question from Lokesh, looks like we could use jobconf instead of job separately. We have to use both actually. So file length input format basically for the fixed length files, and you could use uh, okay, actually here let me try what happens when I say this dot set what do you call set record length. Okay, so you can say that. All right, you can pass the conf object. So actually this job and job conf is some terminology which is being used interchangeably across MapReduce too. The idea of job came in the MapReduce 2 while job conf has been there since MapReduce 1, but it's okay to use this kind of format. Still everything is it works. All right, so this was a quick about fixed length input format, and then we have key value text input format. Sometimes we are dealing with a lot of key value pairs. Our data is in the form of key equals value, like you must have seen in the MS-DOS there are property files. Similarly in Java you have property files. The data is in the form of key value. Okay, so it's a so in those cases you will have to specify in the job dot set input format key value text input format, and then the files will be broken into lines, and either slash n or slash r are used to split the line, and each line is divided into key and value parts by a separator. So there are two separators, one that separates key and value, other that separates the one pair from another pair. By default, the pairs are separated by slash n or slash r, and you have to specify this particular config parameter in order to specify how is your key and value separated. By default, it's colon. Okay. Next is an interesting file format. It's called sequence file format. It's sequence file input format. And this format has been devised specifically for binary data. Be it a movie, be it a music, as in MP3, MP4, or be it a zip file, be it any other binary, most of those have a similar structure internally. Most of those are big flat binary files, and they have a header, and this header dictates various properties of this file. To understand a sequence file, you can take a look at this here. Okay, it's a file that contains binary key value pairs. It's extensively used in MapReduce as input format, and it's worth noting that internally the temporary outputs of maps are stored in sequence file. This is a very important part. So, and sequence file itself has three different kind of input formats: uncompressed and record compressed, only values are compressed, and block compressed, as in both key and values are separately compressed. Okay, and there are further versions of sequence file, and there has been a major change. There has been quite a work done in sequence file. Okay, so it has got a header and got a various sync markers. Okay, so it has got sync markers, as in there are markers so that you can break down the full file easily. You can load the full file easily across the cluster. Okay, so a sequence file, if there is a sequence file, a huge one, and you want to run a map reduce over that sequence file, okay, it's quite convenient, right? Imagine that there is a big binary file and you want to run MapReduce against it. Usually when we have a binary file, you have to bring all the parts of it together in order to run it. Imagine, okay, let's take a step further. Imagine that we had a million images, million profile pictures. Okay, so imagine you have 1 million profile pictures, right? So what you did was, because if you store these 1 million pictures, each of say 10 kilobytes, if you store these in a file, what would happen is, for this what do you call, how much it will be, 10 gigabyte, right? Not 10 gigabyte, yeah, 10 gigabyte. So it's a 10 GB data, and it'll take a lot of space. Okay, it'll create 1 million separate blocks in the file and so on. But if you have 10 GB, how many blocks it will create? Quickly, 80 blocks, right? So it's generally, if you're dealing with so many small files, it's generally advisable at the HDFS level to actually combine all of these together in a single zip file and put it there. Make sense to you? No? So imagine the plight of somebody who is managing the profile pictures at LinkedIn. There are 10 million pictures, say 1 million pictures, profile pictures, each of 10 kilobyte, and they need to store that in HDFS. So it will consume the metadata at name node equal to 1 million blocks, right? Instead, if we create a single zip file out of all these, it will have only 80 blocks. That would save a lot of name node metadata. Make sense to you? Am I audible? All right. Now, the problem is, if we zip it, this is what we're going to do. But at the same time, what happens when we want to run MapReduce? Okay, let's say you came up with the idea that I will just take everybody's profile picture and find out which ones have darker ones. Okay, will clear the keep a threshold of, say, the certain color combination, and then try to predict which images are too dark for the profile picture. All right, so, or which images are not having correct boundaries. Let's say that's your role. Okay, so what would happen in this case if you are to do that? In this case, all these 80 blocks will be have to will we will have to bring it together on single machine and then run our MapReduce, right? Because to unzip a zip file, you have to have all the blocks together and then unzip it. Instead, a better idea would have been, because we don't want to compress it right now, we should have a uncompressed profile pictures. Okay, so in the form of sequence file. So we create sequence file from the zip and then store it. Store it in HDFS, and then while run MapReduce over with input format called sequence file input format. Now question is, when we run a sequence file input format over this in our MapReduce, if we have the sequence file input format, the key and the value that our the key and the value that our MapReduce is going to get, the input key value for mapper is going to be name of the file, name of file, and binary object representing the image. Are you with me? So yeah, Ella, you have a question for me? Okay, so again, let's try to answer the question again. Looks like the definition of the sequence file is not clear. Let me try explaining again. So sequence file is a data format for storing huge binary objects. It's a data format specifically designed for Hadoop, such that huge file could be distributed, huge binary file could be distributed across cluster. And specifically, it's used for very small files combined together and being run against MapReduce. And the example I have given you is the classic case. So again, let me reiterate. So a sequence file is a kind of format. The way you have zip file, you have jar file, you have tar file, and you have, say, a rar file. Similarly, is a sequence file. A sequence file is a binary format in the form of key and value, and it has a header. Header contains the detail about the file, like what is the size of file, where is the marker. So the sequence file contains markers so that the data could be divided amongst multiple machines easily. Okay, the way you have slash and slash something, so that input splits could be created based on the marker. So sequence file is designed in that way to assist MapReduce as well as HDFS. Okay, while HDFS, because sometimes you have to store too many small files in HDFS, so you can combine them in a sequence file and dump it in the if there are too many files, you can concatenate all of them and create, I mean, you can create a single sequence file out of millions of files and then store it in HDFS. And since sequence file has been designed for MapReduce such that the data can get parallel and therefore it's used. So let me again go through the case study which I was going through. A question, okay, let me put it. So question from Ella. So is it metadata, say, of images we are talking about, or combination of metadata and image? So image will take the same size, but metadata will be too huge. Okay. So again, let's take a look at the numbers. Imagine that you are somebody who is planning to do certain churning of LinkedIn profile pictures. There are 1 million pictures, and each picture is approximately 10 kilobyte in size. Okay. So okay, if you do not compress it, there are going to be 1 million files, right? If you have 1 million files, for each file there is one data block, and therefore uh, too much metadata. Okay, too much metadata, right? Will consume, it will hurt name node. So too many files, too many small files are not great for HDFS, therefore it's not a good idea. So what people did was, in those cases when we reached this situation, we combined all these files together into a zip file. So now we have got 10 gigabyte of single zip file containing only 80 blocks. But when you run MapReduce against this single file, it's not separable. It's not separable. There is no way that each section of zip file, each block of zip file can be uncompressed without needing the whole file together. You remember that if we split a single zip file into for multiple floppies, or multiple parts, you cannot unzip without needing other parts. Therefore therefore zip is not a great format for a distributed computing, and hence a sequence file was created. Sequence file input format was created such that each block could be converted into key value pairs, could be loaded separately without needing all other parts of the block of the file. So sequence file from the zip. So generally what we do is we basically create sequence file from all these images and then store it in HDFS and run MapReduce with input format called sequence file input format. All right, is everybody with me? So this was sequence file was specifically created for this kind of. Okay, so the sequence file will basically be of equal to the actual data size, but it won't hurt name nodes because there is only 80 blocks, and 80 blocks means only metadata of those 80 blocks will be stored in the HDFS name node, and therefore sequence file is great for this kind of circumstances. Okay, so a question from Liu Song. Can you explain a bit about Parakeet? Parakeet is another format for sequence binary format. Okay, there are many binary format, but Parakeet is not actually competitor of sequence file format, because sequence file format is the only one which is best for MapReduce kind of circumstances, while Parakeet is somebody who is competing with say JSON, and say what do you call it? What was that? Buffer, protocol buffer from. And what was the other one? There is one service. I forgot that. Okay, so there are many formats to represent your data generically, so that the upgrade of the data, the versions, and everything can be tracked. And Parakeet is one such format. All right, we'll go into the rest of it now. All right, now, okay. So most of the zip files, star files, can easily be converted into sequence file. Now the other important, there are many other input formats. So let's say today you decide that you need to have XML input format. So actually XML input format is available as part of Mahout, guys. Okay. So not this one, not this one. So it's actually a part of the Mahout, yeah, this is the one. So Mahout has provided XML input format so that you can use, and there are say JSON input format for Hadoop. Okay, so you can use JSON input format. So almost for everything you would find a JSON input format. Next, you might be interested in another thing called, say, let's say you are working on say spatial input format. So let's say you're working on maps of the world, and you want to process sections of the data using MapReduce. In those cases, you could use an input format that has been designed for MapReduce. Okay, so most of the distribution of the work starts with choosing the right input format. Okay, so there are quite a few examples of uh, where are, okay, so you will find the input format for all kinds of use cases. So question from Yogesh is, are there any tools to yes, there are many tools to create a sequence file, and you can actually take a look here as well. So where was, so create sequence file. Okay, this is it. So you have sequence file writer. The sequence file.writer is a Java API to talk to the Hadoop, to talk to the sequence file, and you can create sequence file. And there are, cool libraries like convert jar, convert zip into sequence file. Okay, so there are actually libraries which provide you all that. All right. Okay, so the next thing we want to do is, so that was one. Right. Okay, so sometimes you want to create splittable zip files. The alternative to sequence file sometimes is your ggip splittable sometimes. So there are these nice tools which can create splittable gzips. Or you might want to there was another, so there has been a lot of research on storing data in hdfs such that you can easily split the data while running the MapReduce. One of the cases was Algedo format. Algedo is the compression. Algedo is a compression of plain text file such that every section of every block can be decompressed easily. So generally, Apache logs inside HDFS we tend to store with Algedo compression. Okay, so that it takes a very small space. And while decompressing, we do not need to transfer all the data to one node and then decompress it, all the blocks together. So Algedo is one such format, splittable gzip is another, and the the in case you have very small files and a lot of them, you generally create sequence file out of all of those. Okay, now a little bit more details into this. So in case you want to create your input format, you are not happy with existing input formats. You can create input formats by yourself. Okay, and how do you do that? First, you extend a class called input format, and then first thing you do is you implement this function called get splits. Okay, get splits. It gives you the splits, the list of splits, and then you create a record reader. And this record reader's duty is, given an input split, it convert it into list of records. That's the duty of input format. And sometimes you also want to change the behavior of input split. In those cases, you can extend input split. You can extend input split. By default, you have to provide the meaning to get length and get locations, and rest, in case you want to add more functions, you can add to it. All right, so you can change the behavior of input split, change the behavior of input format, and you can create your own input format. All right, so creating an input format is little more involved than it looks like. Okay, and I will try to show you the diagram. And all right, and as an example, there is a second what do you call, second example in this. You can download the second project and you can see the where we have tried to create our own input format. Okay, so download the second project, and that should give you the input formats definition. So you can take a look at, this is our custom file input format. This custom file input format um, is essentially, where is that? Yeah. Custom file input format extends file input format rather than input format. And then it provides a record reader, create record reader. It provides the function is splittable and so on. And here it provides a definition of the custom line reader that we have used here, and custom record reader. Okay, so you can take a look at this as an example. So it's a little bit more involved than it looks in the upfront. The core logic is that the reader, the input format will keep on reading across the boundary the unless the record boundary has been reached. Okay, it will keep on reading, or you can say that the on a node the input format will keep on skipping the bytes unless it reaches the end of the previous record. Okay, so here in this diagram, on all these machines, when MapReduce is started, input format starts the work. On input format, when input format starts the work, it starts in the beginning, right? Parallelly, the process is going on parallelly. That's very important. So on every node, it will keep on skipping the data unless it notices a boundary. Okay, either notices the boundary, beginning of the file, or end of the file. It'll keep on skipping the data unless it reaches a boundary. Say, for example, on this machine, the the input format will keep on skipping the data for the previous node unless it reaches the boundary, and from there onwards it will start creating its own records and input split. Similarly, on this node, input split starts here and then will keep on skipping the data for the previous node unless it reaches a boundary here. Okay, so that was our discussion on input formats. All right, we will take it from here. There are few more concepts that are required. One is partitioner, other is combiner, and then data locality and speculative execution. These are few important concepts. We will discuss it during next session. All right, and then in the next session we are going to start with Pig Latin. Okay. In the next session, we are going to start with Pig Latin, then we'll go with Hive and HBase and rest of the tools. All right. So please finish the assignment and then we will discuss the rest. All right. Thank you very much. Have a great day. Bye bye. From the slide number 48. All right. Bye bye. Have a good day.